So we left off yesterday here with Miss Bruce. I'm going to erase this and we're just going to re-talk about this. Okay, so we read the question, right? And she said, what you want to make sure you do, they've given you both equations. Like, they gave you the velocity. You don't even have to take the derivative yourself to get acceleration. They gave you both of these. So we're going to put them in the calculator. Now, when you do this, you can't call them v of t and a of t. It's f1 of x, f2 of x. So we're going to put v of t. This is going to be your f1 of x. And then a of t, this is going to be your f2 of x. Okay, so that's like the first thing you do. And so if you just started this, we're going to add a calculator. And then I want to add another page, so control doc, add a graph, which is 2. And then we're going to type them in here. Right? And we labeled which one is f. Like, don't just put them in there. Make sure you know which is which. So f1 is my velocity, so that's going to be 2, remember trig, sine of e. And you can't use t. It has to be x divided by 4. My parentheses are closed, so I arrow over, plus 1. Okay? So then I hit enter. Now, if you're here and you need to do another one, what are we stuck on? Got it? Okay. I've put one in and I hit enter. Do you know how to get to where you can put in another one? Okay. The what? One of the arrows? Oh. There's another way, because I never can figure it out, because it doesn't really make sense. If you hit tab, you get back up there. You have to add a graph and add a. Did you do that? Yeah, go home. Okay, never use Scratchpad. You're over here. New document. You don't want to save the old one. No. No Scratchpads.
So I did press that. I'm not sure if that's anything else.
Okay, so it gives you. Oh, I'm sorry. We're going to escape. Why is it gone? Where is it? Oh, because you wrote it as y equals. That's why. So it's not even counting it as a function.
Okay.
So, yeah, you definitely don't want it to be a y equals. Yeah. It's on your paper, dear. One half e to the x divided by 4 times the cosine. Oh, nope. Okay. And your two graphs should look like that. What are you doing? Oh, I have a feeling it's because neither one of y'all listened to me. You cannot use t. You have to use x. Okay, good. Well, we'll get there if these yahoos would ever get things typed in. You have both of them in there? You need both of them in there. Y'all, come on. Good Lord. Wait, what are we doing? Okay. Oh. Okay, you have F1? Oh, yeah. I do not. Well, just go get one. If you need one for that, just go get one of my calculators. Y'all act like you've never used technology before.
Yeah, y'all are like 8 years. Dude, come. It's too much. Where's menu? Josh. I've been looking at this. This is the
Let me see your graph. Yeah, I saw one. Okay. You got it? Okay, good. Okay, good. Y'all know you only got 15 minutes for the whole problem, right? Just saying. Whew. It's painful here. Look, if you can play video games, if you can use your phone, why can't you type things on a calculator? I'm old. I can do it faster than you. Yeah, I'm a teacher. What the heck do I know? Old? It's okay. Yes, I know. I know. Sister's like 40 now. No, I'm just kidding. All right, are we ready? Do we have this? Something that looks like this? Whew. Okay, so we may not actually need, so if we look at what this problem says, if we look at our x values, which are t values on here, everything says from 0 to 6, from 0 to 6, from 0 to 6, right? So it may be helpful to go ahead right now and fix our window so x goes from 0 to 6. So we're going to hit menu. Window zoom, that's 4. And we're not zooming in, we're not doing any of that. We want our window settings. Oh my gosh. Dude, come on now. You hit menu. Window, 4. Window settings, 1. We want our x minimum to be 0 and our x maximum to be 6. Y does not matter right now. It may matter, but like right now we're just going to worry about our domain. Where did I get those numbers from? Where did I get them from? The question. Then I can hit enter for OK, and now I'm from 0 to 6. Okay? We all good? Okay. Everybody have this? Okay. Now, let's go back and see what we were doing here. We're going to do A. And A says, is the speed of the particle increasing or decreasing at time t equals 5.5? How do we figure out what do we need to know if we're trying to figure out if the speed is increasing or decreasing? The signs of what? Of acceleration and velocity. So I need the velocity of 5.5, and I need the acceleration of 5.5. 5.5. Nope, because it's going to give us, Well, that's fine. I mean, it is kind of an estimation, I guess. I mean, you can, but really, as long as it's accurate to 3 decimal places, we're okay. Does that make sense? Yeah. Not for that, because this is not. I mean, technically, yes, it's an approximation because we're rounding on the calculator, but we're not approximating like a true estimating. You see the difference? Yes, yes. Okay, so here we are. So let's go back to the calculator. And again, y'all listen, you can't just willy-nilly put these in there. You have got to make sure you know which one is F1 and you know which one is F2, or things are going to go very badly for you. So we're going to go back to the calculator. I don't want my graph anymore. I want to go where I can calculate. I mean, I'm not clearing that out. That's not what I meant. Like, those need to be in there. But I'm going to go to the other page. So turn my page. I'm back here. And I don't know why I can't. Why is this? Let me move that guy. Okay. So I'm here. I don't want to have to type all that mess in again. Especially, I sure don't want to wait for y'all to type it all in again. So I want f of 1. There's 2 different ways to do this. One way is to hit the variable key right here, and then choose F1, and F1 of 5.5, and hit enter. That's why you want to put it in there even if you don't care about the graph. Okay? So what we get then here is we get this is negative 0.45337, right? Well, it has to be correct to 3. I put 5, but 3 is fine. All right, so then let me show you the other way. If you don't want to hit the variable key or whatever, so now I want to use F2. I can literally type F2, open my parentheses, 5.5, close my parentheses, and it will take care of it for me. Okay. I just typed in F2, like from the keyboard. Either way works, whatever you find better. This is negative 1.3585. Okay, so is this speed increasing or decreasing? Increasing. Okay, so I would say then, because it says explain, the speed of the particle is increasing because V of 5.5 and A of 5, there's other ways to write this, but A of 5.5 are both negative. Here's what you can't say. You can't just say because they have the same sign. If you say that, you still have to say if they're both negative or if they're both positive. You could say the velocity and acceleration are both negative at t equals 5.5. That's fine also, but since I put it in there, I didn't have to say that. So is that how you wrote it? The speed of the particle is increasing at time t. Yes. Yes, that's beautiful. That works. Okay. What questions you got? Anything? All right. Let's do B. So B says, find the average velocity of the particle at the time, for the time period 0 to 6. So same thing, average velocity, right? So if I have the average velocity, I have the velocity and I have acceleration, those functions, I want the average velocity. It is not, because that's going to give me the change in acceleration, the change in position. No, the change in acceleration. No, we're still using velocity. Let's think about how we find the average of something. We add it all up and then we divide by how many there are, right? So what we need is the total velocity over the time period divided by the time period, right? So that's when you do your average values, 1 over b minus a, 6 minus 0. And then we're integrating velocity. Okay, because this, remember when she was talking about this yesterday, this gives you the total velocity divided by the change in time. Okay, so that gives you the average velocity. We okay with that? Okay, so when we do this here then, we're going to do this on the calculator. No, I just wanted to make sure you knew where it's coming from. So on the calculator, we're still here. We're going to do, I like to use the fraction because I like for it to look actually like what I have. So 1 over 6. And then this is going to integrate for me. We're about to get there. Does everybody have 1 over 6 in their calculator? All right, so now we hit menu. What do we want to do? Calculus, 4. What do we want to do? An integral, number 2. Okay, then we put 0 at the bottom. Arrow up, put 6 in the top. Now, was our V F1 or F2? F1, so I can pick F1 here, and I have to put F1 of x, and then I have to say dx. That's it. Boom. That gives it to you. So then this is 1.949, and I don't think this problem has any units on it or anything, does it? No, it doesn't. So it's just 1.949. That's the point. You good with that? So you still have to know how to set it up. You still have to write this down. You cannot just type it in the calculator and get that. This setup is part of your answer. Okay? You don't have to write out the equation. V of t is fine, but you have to actually write something down there. We good? Ask me a question. Kevin? You good? Okay. All right. C. Find the total distance traveled by the particle from time t equals 0 to t equals 6. How do we find the total distance? I got to do an integral. Yes. It's the integral of the absolute value of v of t. Because remember, that's different than displacement. If I don't put the absolute value, then that's just displacement. Make sure when you write your integral that you have your limits of integration, that you have the absolute value, and that you also have your dt there on there. Okay? Everybody good? So now we're going to go back to the calculator, and we're going to, I need the integral symbol, so menu, I'm doing calculus, I want to take an integral, 0 to 6 again. Now let's talk about the absolute value sign. You have two options here also. You see this straight line over here? That's not one of them, okay? Just so you know. You can type in the word, you can type in ABS for absolute value, but I don't know that you would necessarily want to do that. But you see right here next to the 9, this little button here? We're going to push that button, and then that gives you all kinds of things, right? Here's the absolute value right here. Okay? Absolute value is right here. And then we hit enter, and we're integrating velocity, right? So that was my f1, so this time I'll do it as f1 of x. You can do it different ways. And then this is dx, just like that. Okay, we good? All right. And that's what we get. 12.573. What question do you have? Nothing? Okay. So, from 0 to 6, the particle changes direction exactly once. I want to find the position of the particle at that time. Okay. So, how do we know from one of these graphs or from the function where it would change direction? Is that right? What do y'all think? What has to be 0 when we change directions? How do we know we're going to the right? When it's positive. When what is positive? No, I can be moving to the right, but my position be negative, right? Because if I have, so if here's 0, right? So I could be here at -3, and I could be moving to the right, but my position is still negative, right? When are we moving to the right? What is positive? Velocity. When velocity is positive, we're moving to the right. When velocity is negative, we're moving to the left. When velocity is 0, we're not moving, but we're also not going left or right. So that's when a change of position could happen, okay? Change of direction could happen. So not necessarily always, but if I'm changing from negative to positive, so if I go back and I look at this graph, okay? If I'm not sure which one is which, that could be a problem, right? So if I hit tab, then I'm going to arrow up. Okay, I want to just see my velocity graph. So where this F2 is, if I uncheck it, then I won't see F2. I'll just see F1, and then I won't be confused about which is which at this point. You with me on that? Okay. And then it tells me, it says, oops, that's not what I wanted to do. Get rid of this. It tells me that it only changes direction once. So my velocity is positive, I'm moving to the right, then my velocity is negative, so I'm moving to the left. So right here is where we change direction. Make sense? All right, so I need to know, so I know that velocity v of t is equal to 0. That's what I want, and I need to know when that is. Okay? So how can I figure out when that is from this graph? It's when it's 0, right? So I want to figure out what my 0 is. So I'm going to do menu. What am I trying to do? I'm trying to analyze my graph. That's 6. How do I want to analyze it? I want to find the 0. That's number 1. So then I have this. So then I want to move this. I need to start. Oh, no. Okay. Sorry. I can't undo. There you go. I'm going to move it to the left. So it needs to be to the left of the 0. I hit enter. Then I'm going to move it to the right of the 0, and you see how it kind of highlights it? Okay? And then I can hit enter. Now, I cannot use 5.2. That's all I can see, but that's not what I use. Okay? I have to, and I don't type in a decimal. I need it to save this decimal. So we are going to, and unfortunately, there we go. You want to make the little hand kind of grab it like that. And then, hang on a second. There you go. And double click there. So it highlights it like that. Do we double click and highlight? All right. So then I want to store it, right? Control, store. No, that's not right. Okay, hang on. I can't do it on the board. I can do it on the calculator. Escape. I don't want to actually select it. There you go. Select it without it with the little thing in there. Does that make sense? Without the flashy thing in there. And if you accidentally delete it, just hit escape and it'll come back. Then I want to store it. There we go. And something like when you hit control variable for store, something like that should pop up. Oh yeah, that's fine. That's actually I think what it is. Isn't it? No. Did you find the 0 or?
Yeah, except instead of rounding it to the tens place,
Oh, okay. Are we good? Are we there? Why not? What's the problem? You have to get the little hand there.
Highlight it.
Yeah, and then you double click, but not with the flashy thing in there. You have to find the right. I don't know. How did y'all do it on the because I've been doing it on the calculator and I can't do it up here the same way.
you just kind of hover until you see the hand, and then you click it, and then
Yeah, you just click it. So the flashy thing it needs to say this when you do it, when you hit enter. That's okay.
How did you do that?
I think without the hand is the problem, right? Or with the hand?
With the hand, it covers the whole thing without the hand.
Okay. Okay. Now, what we don't want is we don't want to call this x, because we already have an x, right? But in our problem, we're really calling it t, so we can just call it t if we want. Oh, no, it doesn't like that. Hang on a second. Crap, what is wrong with my... Oof. Hang on a second, I don't know how to get rid of this. What is going on here? All right, guys, I have no idea how that came up, and I don't know how to get rid of it. So, okay, once it's here, there we go. Once it's there, control variable to store. Apparently T is a bad idea, so we'll call it A. How's that? You can call it whatever you want as long as you know what you called it. And then it's bold once you've stored it. Yes, you can click it. After you put a variable, you click enter. Okay, we're good? All right. So we're good? We have it stored? All right. So let's go back and think about what we want here. So t is like 5 point something, right? So it says, the particle changes direction exactly once. Find the position of the particle at that time. All right, so what I want is I want the position. I want x of a, because we called it a, right? I want my position. What do I integrate to get position? Velocity, okay? So when I integrate velocity, all that tells me is the change in position, right? Where did I start? So this x of a, this is going to have to be equal to x of 0 plus the integral from 0 to a of the velocity. So let's think about that. I'm going to integrate velocity from 0 to a. That's the value that we stored, right? This is really a. And I have to add to that my initial position. Do we know our initial position? Yes. What is it? How do you know that? It says it in the question, right? So x of a, which is what we want, is our initial position plus the change in position, plus that integral from 0 to a of b of t dt. So in my calculator, that's basically what I'm going to put without the t's. The t's will be x's. So in my calculator, I'm going to have 2 plus. How do I get the integral? Menu. I want to do calculus. I want to take an integral. I'm going from 0 to what? A, because I called it A, right? A is stored in there. And v of t is really f1 of x. And then dx. Boom. 14.135 or 1347. What question do we have? We good? So this is equal to 14.1347 or 135 or 134. I'll take that too. But do not ever use a rounded number, and don't ever round to the nearest tenth. You can put 1,000 decimal places if you want, as long as you're correct to 3. Not that you want to put 1,000, I'm just saying. Right. What questions do we have? Yes, if we have one. If not, I can create one, but it might take me a while because I'm not sure what all I would need to put on there. You know what I mean? Like, I haven't done it enough to know, oh, I should have told them this. That'll be my document. Oh, add this to it. Oh, add this to it. Maybe we just need to start a running document of what to do. Yeah. Yeah, I know. And I asked Ackerman the other day, I said, are we going to have a time? Because when I was working through these, I was kind of, it was taking me a minute to push the button, like grabbing that freaking number. I know there's an easier way. And I just you got to figure out what makes the most sense to you. I said, are we going to have some more where we actually practice on the calculator? Because if not, we're all going to be stumbling through it. And he said, yes, we're about to get to that. So I'll sit through, and as I work through the other ones, I'll think about this is what we need to write down, and I'll find a click sheet or something for that. I bet you somebody has one, like Ms. Bruce might have one. Or I also feel like, and what I kind of wanted from the beginning was just a practice thing, like, hey, store these numbers. Hey, do this, and just kind of like do these basic things individually of everything and not in a question, just to practice doing it and finding it. So, I know. Well, that's why when I'm talking you through it too, I want you to think, I know that you're not very familiar with this. I'm not either. But I think to myself, okay, if I need to do something, it's probably in the menu. So I'm going to click menu. what am I doing? Well, I'm doing calculus, and then, hey, what do I want to do? Like, it kind of is a little bit intuitive, but I know it's not the same as everything else that you're used to. Okay. What questions you got? Anything? All right. So maybe it wouldn't hurt to go back to this problem in a couple days, do the exact same problem, and just push all the buttons to make it happen to make sure you can still get it. That's not a bad way to practice either. We good with that? All right, let's look at the next one. All right, so this one's a non-calculator one. Do we want to do another one that's calculator right now, maybe? And skip over that? Well, we have enough time to get started on things. Let's go to 2009. Yeah, let's do the next calculator one. We can come back to this. This one? Okay, y'all find this one. All right, here we go. Is everybody looking at this question? 2009, question 1, calculator. Okay, so Karen rides her bicycle along a straight road from home to school. So this graph is v of t, right? It's not position, it's velocity. I know it's labeled, but label it bigger for yourself. Starting at t equals 0, arriving at school at time t equals 12 minutes. During the time interval from 0 to 12, her velocity in miles per minute, so here are my units, we're going to have to make sure we pay attention to units on this one, is modeled by the piecewise linear function whose graph is shown above. Okay? I want to find the acceleration of Karen's bicycle at time t equals 7.5 minutes. Okay? So here's 7.5. I want the acceleration. How is acceleration related to velocity? It is the derivative of velocity because acceleration is the rate of change of velocity, right? And so if I have the velocity function, I need to find the rate of change. And you want to be very careful here because, yes, this looks like a slope of -1, but it's not because of our units. See our units here? Okay, so we want to be very, very careful. So instead of just saying, oh, I know it's -1 because we're used to looking at it like that, we can do this. A is equal to, okay, I gotta look over here because I can't see it anymore. Not A is equal to, I'm sorry, part A is what I'm trying to do. I want the acceleration at time 7.5, right? So that's just the slope of velocity. That's all it is. And because this is linear, we can find the slope. So I can find the velocity at time 8 minus the velocity at time 7 over 8 minus 7, right? And I did not willy-nilly pick those numbers. I can't use 9 and 6. I'm using 8 and 7 because they are basically the endpoints of this little segment, okay? So I can make sure my units are correct on all this. So what is v of 8? 0.2 minus v of 7, which is 0.3 over 1. Okay, and this is a calculator question. You can leave it like this, but you might need the number. So since you have a calculator, what's 0.2 minus 0.3? 0.1, negative 0.1. And then it says, what are our units? So I want you to think about this. We had velocity up here. Okay, so our velocity is in the numerator, right? What are the units on velocity? Miles per minute. That was our numerator. And then we divided it by what? Minutes. So it's miles per minute, or miles per minute squared. But the units, a lot of times, I don't have the scoring guideline right in front of me, but a lot of times the units are part of that's the whole point, just making sure you understand the units, okay? What questions you got? We good? All right, let's look at B. So B says, using correct units, explain the meaning of the integral from 0 to 12 of the absolute value of v of t dt in terms of Karen's trip. Then find the value. So what is the meaning? So let's write this out. We can write down 0 to 12, v, absolute value v of t, dt. Okay. This is, okay, it's the total distance. Is that what our absolute value gives us? Okay. Is the total distance in what units? Distance in miles. Karen drove, what did she do? Okay, she rode, sorry, I put, rode from t equals 0 minutes to t equals 12 minutes. Make sure that you always include your units, your time, your distance if it's there. All right, so now we need to find it. So one thing we didn't do is we didn't put this in our calculator to begin with, which we should have. So let's go back over here. I'm going to go home. I want new. And no, I do not want to save this unsaved document. Ugh, I do not like this on the board. So I'm going to add a calculator. And then I'm also going to add a graph. Okay? And then I always put the function in the graph, okay? So, oh wait, I don't have to do that. I'm not doing that. What am I doing? No wonder we didn't do it. They didn't give us. We have the picture. I'm making stuff up. Oh, duh. All right, so we're doing this geometrically. It's up here. How do we integrate if we have those shapes? Find the areas. Math, yeah. Okay, so let's find all our little areas here. So this is 2 times 0.2 divided by 2, which is 0.2. This is 2 times 0.2 divided by 2. That's 0.2. Then you can separate these however you want to separate them, maybe like that. So this is 1 times 0.3 divided by 2, which is, yeah, 0.3 over 2, which is 0.15. But 0.3 over 2 is fine too. Then we have 1 times 0.3, which is 0.3. 1 times 0.3. Yeah, that's fine. Well, you did what trapezoid? But it's not a trapezoid. Yeah.
Left side on the 7.
That's what I did.
But he didn't separate it twice.
Oh, you did this trapezoid. Okay, sorry. Yeah, you can't, because this thing is not a trapezoid. That's what I was looking at. All right, so then I'm going to add 0.2 plus 0.3. That's 0.5 times 1 divided by 2 is 0.25. And then I have a trapezoid here, right? But I think I would do a rectangle and a triangle. So 3 times 0.2 is 0.6. Then 1 times 0.2 divided by 2, 0.1. Okay. Now, we just said that this is the total distance traveled. Do we cancel, these two things cancel themselves out? No. She left her house, then she came back, and she left again, right? And she was at her house for a little while. So that's still the distance traveled. So since it's the absolute value, we actually include this. So that means that this would be, so the integral from 0 to 12, absolute value v of t dt. It's not like you add it all up and then you take the absolute value. You take the absolute value as you do it. So this would be 0.2 plus 0.2 plus 0.15 plus 0.3. No. But I did, so I'm going to right now. And, oh, I do have the total. It's 1.8 what? Miles. What questions do you have? Are we good? All right, so let's talk about C. We have the calculator part is only on part D anyway, so those of you that take a year to type this in, you might be off the hook on this one. On C, it says, shortly after leaving home, Karen realizes she left her calculus homework at home, and she returns to get it. At what time does she turn around and go back home? And give a reason for your answer. When does she turn around and go back home? At minute 2. How do you know that? Okay. How do you know she's going left? V of t is negative. So this is where she turns around and goes home because velocity changes from positive to negative. Okay? So how to answer this here? Let's see. At what time? Okay. So Karen turns around. At t equals 2 what? Minutes. And we know this because v of t, or we can say, or her velocity, or v of t, changes. And I can't just say changes signs, it changes from positive to negative. Oh, hot. Or we could have said because velocity changes from, v of t greater than 0 to v of t less than 0, however you want to say it. There's different ways to word it. What questions do you have? The D part is the calculator part. I want you all to actually try it. Actually try it before you show up again on Monday. Got it? Okay.